Differential equations, we're in section 4.2, day 2. Today we're going to derive a formula, and it's to help us solve a second order homogeneous differential equation. And it's going to be very much like a formula that you have used in the past, like with the quadratic formula. Of course, its appearance will look way different. But it's going to have a similar impact. It can speed things up and allow you to get answers rather quickly. So let's just go step by step. This lesson's a little bit different in the sense that we really are going to go ahead and derive it and prove it. So here's what we've got. We've got this, starting point. We have this differential equation, second order. Very importantly, our right-hand side's equal to 0. Divide both sides by that a sub 2 function. And what you're quickly going to see is, you'll have a ratio of functions here. Rather than leave them as fractions, call them p and call them q. And it's greatly going to facilitate the appearance. And we're going to use that p especially very soon in our formula. But let's say that we are given one solution. Again, that can be a bit of a stretch perhaps, but let's say that we know one exists and we're told what it is. Y is equal to u times y sub 1. The next step is to take a derivative. You'd get y prime, a product rule. You'd have u prime times y1 plus u times y1 prime. Then what? Well, we're going to go ahead and do the product rule right here. And we'd take our second derivative of u, that would be right here, times y1 plus, well, we can have our our u prime times y1 prime. So that's really our first starting point, our first product rule. But then please realize we have another product rule that we'd have to move ahead with. We'd have this u prime, take the derivative of the first function, y1 prime right here, and then plus we'd have a u y1 double prime. Now it's only going to take you a moment as you look at this to see that there are two like terms here, a u prime, y1 prime. There are two of them, so that would become a 2 u prime, y1 prime. And that's just preliminary. That's just showing the three things that we're about to substitute in. Remember, we're up here in green. And we're going to say, hey, y double prime. Well, we're going to plug that y double prime in here. What do we get? Well, we're going to get this. Just recopying it is all we're going to do. Then we're going to say, well, we've got our p of x times y prime. Well, recopy our p of x. But then take your y prime and plug that in. And that's what we've got right here. We're just going to rewrite it in that regard. And finally, we'll say plus q of x times y. But what's y? Well, it's what we started with right here, right? It's going to be u y sub 1. So it's right here where it looks rather messy. And it's looking quite a bit messy, dare I say. But I do want to point this out to you. We could begin a search, if you would, to just say, well, maybe we could gather some like terms. Let's see if there is something with a u in it. By the way, we'd have to distribute a p of x in there. And it doesn't take too long for kids to say, well, everything that I've just highlighted in yellow would have a u in it. Well, we've more or less just factored a u out, and what are we left with? A y1 double prime. Here, remember, we're distributing that p of x in, so we'd have a p of x y1 prime. And here, we just have a q of x y sub 1. So we're doing a little bit of work there. But then what we could say, well, what about our u double prime? Well, there's only one term with a u double prime in it, and we could copy that out. And then finally, you could say, well, my goodness, the only other thing that seems to be in the mix would be u prime. And of course, we also have this p of x right there. We could factor a u prime out in front, and then what are we left with? Well, you could see that, you would be left with this p of x, y1, and we'd also have this 2 y1 also, right? y1 prime, pardon me. So it doesn't take too long to reconfigure everything, but here's what I do want to call to your attention. The fact is, this form in green is super, super, super important, not just because of how we're going to use it in our formula, but also the fact that this is homogeneous. The right-hand side is 0, and all of a sudden you'd say, now wait a minute, this whole thing right here is 0. So when you multiply u times 0, it's gone. It's completely gone. And then what? Well, from here, you're just left with what remains. A u double prime times y1. You've got your u prime with that parenthesis that we see right here. And it's at this point, guys, we're moving right along. Again, we're trying to do a little bit of a proof here. We're going to do a little bit of a substitution to have a reduction in order. We're going to say, look, we've got a second derivative. Wow, it sure would be nice if we could look at this as if it were a first derivative problem. So what we do is we're going to say, let's let w equal u prime, and let the next derivative, w prime, equal u double prime. And it won't take you long to make these substitutions and to quickly clean them up. Now over here, we just are going to put our u prime, which is w, after the parentheses, and we're going to come right over here. You might say, did that really help? Honestly, it did. Here's why. We're now dealing with a first derivative differential equation rather than a second order. But another way to write w prime is to think of it as dw dx, right? And the reason why we've got that, now we're going to, in our proof, do something a little bit different. We're going to multiply every term here by dx. At the same time, and when you do that, you can see these differentials cancel out. At the same time, we're going to do some dividing on both sides. We're going to divide by this w everywhere. We'll be left with this dw all over a w. Here the w is going to cancel out. We're also going to divide by this y sub 1. So in our first term, that's gone. And then we've got this parenthesis all over a y sub 1. So hopefully things are looking like they're getting a little bit nicer, just a tad nicer. Tell you what, while we're at it, we could do a little I heart math right here. My goodness, just cleaning this up, it would be a 2 y sub 1 prime all over y1, y sub 1. Here we'd have a p of x times y sub 1 all over y sub 1. These y sub 1s cancel out, don't they? And it's we could distribute a dx in there very quickly. So this is our new form right here. And we're going to just integrate. It's as if we just integrate each separate part here, including the right-hand side. The derivative of 0 is a constant. That's a c1. Here we've got an integral of p of x dx. This middle one, we could do a quick u substitution. Let u equal y sub 1, and then du would be, let's see here, y sub 1 prime dx. And here's your y sub 1 prime dx right there. That becomes a du. So you have a 2 all over 1 over u du. integrate that, you're just going to get the ln of u, but the ln of u, of course, we're going to assume it's a y1. Just like right here, integrating 1 over w, we'd get the ln of w. So things are cleaning up. Things are getting better. Now we're going to go back this way. They're going to bring the integral over to the right side. You switch signs. You change signs. Move to the other side. You now have a negative out in front. We can bump this 2 up. We'd have y sub 1 squared. But because we're adding, we may condense these logs this way. And then what? Well, we can exponentiate. We're going to go e to the left side. That's going to leave us with a w y sub 1 squared. That's where that's coming from. And we'll have this e to this integral. But remember, when we have e to a constant, like if we had e to the a plus b, that's e to the a times e to the b. E to a constant is just some constant. So that's where that second constant is coming from. And guys, as we are, moving on with this, you can see that we can continue to solve. To get w alone, of course, you'd say, well, how about I get a division here by y sub 1 squared? And that's what we've got right over here. Well, as we continue, you could say, now wait a minute, we had a substitution for w. You might remember way at the start, w was u prime, wasn't it? And so really this left-hand side is u prime. So here's what we're going to do. We just integrate. We're going to take an integral on both sides here. And, the integral of u prime is just this u. And then we'll have our c sub 2 e to the negative integral of p of x dx all over y sub 1 squared dx. Of course, we'll get a new constant coming in. But we're going to choose smart. We're going to say c sub 3 could be 0. C sub 2 could equal 1. And what's that really saying? It's saying u would be the integral of e to the negative integral of p of x dx all over a y1 squared. And this integral is going to go longer, dx, right? So I'll make that integral get a little bit longer just like that. But here's the thing. We started off with y equals y sub 1 u. That means u is equal to, if we divide by y sub 1, we've got that right there. So look at this. This is the beauty of it. Rather than write this as a u on the left-hand side, how about we write it as y over y sub 1? And then just multiply both sides by y sub 1. And guys, that's it. We've done a very in-depth derivation and a proof. You're not going to be asked to officially write this out, but this is an incredible help to facilitate problems. You're now going to be able to very quickly find a second answer and a general answer because of this formula. So we're going to wrap this up right now with this video because, it's one thing to derive the formula. It's another thing to use it. We're actually going to do a couple of problems and show you how to do that in our next video.